Okay. Yeah, we covered the section 10.1, how the finding the Jordan canonical form by using the dot diagram. So, yeah, from a given matrix, yeah, you can find eigenvalues and you can find the A minus lambda I times identity matrix, and you can find the length of the case power of those, and the difference of those lengths will give you the Ri's, which gives you the dot diagram, so you can draw the Jordan canonical form of A. And in section 10.2, it tells us the relationship between Jordan canonical form and generalized eigenvectors. And generalized eigenvector is a matrix, the column vectors of this matrix P that makes P inverse AP is equal to Jordan canonical form of A. We call these columns are called the generalized eigenvectors, and that can be found with these relationships. If we have a Jordan canonical form, yeah, we should have a relationship like that. So from here, yeah, we can observe how to find P2, P3, P4 from the P from the P1. Okay, so from this observation gives us how to find the chain of generalized eigenvectors, Pi's for each eigenvalue for each Jordan blocks, and that's the how to find it. But this is not covered in the introductory course. So yeah, we will start section 10.3, Jordan canonical form and computer algebra system, and how to find the Jordan canonical form with the help of the computational tools. In real life, in order to find the Jordan canonical form of a 10 by 10 matrix, you need to find the root of characteristic polynomial of degree 10 first. Then the factorization and rigorous calculation of these roots is usually impossible. Moreover, 10 by 10 matrix require us to calculate many exponents and coefficients. In order to calculate these coefficients, the Gaussian elimination and related computations can be performed by various computer tools. Okay, and we're gonna use the open source software, Sage Math, and the use of software for computationally complex mathematics is necessary in these days. So in the following links provide more information about the Jordan canonical forms and tools that allow us to explicitly find the Jordan canonical form for a given matrix with computations, without hand calculations. Okay, here is the Jordan canonical form by hand. Here, Jordan canonical form. Here, for example, we define a matrix A like this, and then Jordan canonical form can be found by this command, finding Jordan canonical form, like this. Suppose we have a 4 by 4 matrix, then this command gives you the Jordan canonical form like this. This is a Jordan canonical form. So, yeah, this is an easy way to do it. And next, if we wanted to do a complex rational field, if we need, when we have a complex eigenvalues, then we need to define our underlying field as a complex field. In that case, then we do the computation. If we make the change zone here instead of not using any word or QQ, instead of it, we use the rational field in this way to do the computations. And here, for this type of matrix, and we can find we get here, as you see, we have a complex eigenvalues like this. Yeah, here. This is the imaginary numbers, which eigenvalues. And for this 11 by 11 matrix, yeah, we can find the Jordan canonical form of the matrix like this, and so on. So actually, this code was made with the finding the eigenvalue first, and then do the computation of A minus lambda I times identity matrix, and then compute the power of each of those matrices, and then find the length of those, and find the difference of those to draw this dot diagram, and then give this. If we have the Jordan canonical form like this, then we can find the corresponding generalized eigenvector. We have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Nine eigenvalues of 3. Okay, algebraic multiplicity of eigenvalue 3 is 9. But it only has 3 linearly independent eigenvector. So for each linear independent eigenvector is a corresponding eigenvector for these columns. And then we find the generalized eigenvector, 3 generalized eigenvector from here, and then 2 generalized eigenvector from here, and 1 generalized eigenvector from here, like this, to find the whole 9 linear independent vectors form a matrix Q that make Q inverse AQ is equal to a Jordan canonical form. And so you use those commands that will help you. So that goes, and also this is an algorithmic approaches for finding eigenvalue. Here, suppose you have a matrix A like this, then you find the characteristic polynomial first. Then you have the eigenvalue 1, whose algebraic multiplicity is 3, okay? And then you find the eigenvectors like this. And then find in solve the linear system of equation, and then to find this gives us a chain of generalized eigenvectors. That gives you the generalized eigenvectors, so to form a Jordan canonical form by using the generalized eigenvectors. And this is not what I wanted to you asked to do in the exams. And this shows step by step of the finding the Jordan canonical form of those. Okay. You found the R1 and R2 and R4, and those gives you the Jordan canonical form like this. This is algorithmic approach to find the eigenvalues and solving eigenvalues and finding the lengths and finding the Ri's with this, and to find the Jordan canonical forms like this. So this is algorithmic approach that you can go through it, and this is a command that everything is all together. And also here I gave you this tool which has what the singular value decompositions can be found. No, not this one. And LU decompositions can be found in here, and also here this is the different address. Yeah, I made the Jordan. I added one with the Jordan canonical form in it. Here, find the Jordan canonical form. SVD. Not in here. Anyway, this is the matrix computational tool to finding lengths and determinant and characteristic polynomial and eigenvalues and eigenvectors and LU QR and SVDs and corners and projections. Everything's most of things that I hear. So you can see the code in here to when you need to modify for others. If you copy all of this and then goes to sage.skku.edu, for example, if you copy that command and paste it, and if you do run it, then you will have the same thing. So which means you have a tool already in your hand that you can use it anywhere. Okay. Anyway, that's the way to find the Jordan canonical form with the tools that you can handle. I think that's the end of chapter 10, and you have exercised, and some of you already solved some of these problems, and so I think we are quite ready for the final examination. Any questions? This, okay, and there are sample exams. There are sample exams and solutions here. So you will be ready on those final exams. Any question?